We are now on week 15. Good morning, everyone, or good day, everyone. We are now on week 15 of our discussion on industrial chemistry and tribology. So, our topic for today will be about boiler feed water. This will be our objectives for this activity or for this discussion. Explain the effects of seawater and freshwater to boiler. Explain the principles in analysis of seawater and also freshwater, and explain the purpose of boiler feed water treatment. So this is actually a diagram about how water is being processed in our boiler systems. So as you can see here, we have the makeup water, which is actually a combination of the condensate water, coming from our condenser, returning to the process stream, combining with the makeup water, and that would be our feed water. By the way, this makeup water is of high quality, either fresh water or supposed to be a treated fresh water supply. And it is being mixed with condensed water or condensate water coming from our condenser. And this will be being supplied to our boilers to produce our steam for production of energy and also power inside the vessel. So we talk about boiler feed water. It is actually made up again of a recovered condensed water, also known as a return water, and fresh water that has undergone varying levels of purification, which is our makeup water. So doon na siya a combination, condensed water, condensate water, and also our makeup water. Natural water is typically used for makeup, either untreated or after some kind of treatment. But I would suggest if you will be engineers someday in charge of this, you also need to treat your freshwater supply so that jutay lang yung problems natin along the way inside the boiler. Therefore, the makeup water's quality and the amount of condensate returned to the boiler affect the composition of the boiler feed water. So these are actually the water parameters, no? So we always start with the water parameters para mas widen natin perspective. Why do we do analysis and at the same time, why do we study boiler feed water? So number one would always be the pH. So one of the most essential water quality metrics is pH. It is defined as a negative logarithm of the concentration of hydrogen ions. So we will not be solving any problems related to pH, but we all know that when the water is acidic, it has more hydrogen ions on it, causing corrosion. And once our water is basic, it has more hydroxyl ions. And we also know last time from our discussion that hydroxyl or OH or hydroxides could also cause scaling naman on the other. So when we have acidic water, we have corrosion. When we have basic water, surpassing the limit, no, 11.5 na level, it could also cause scaling inside our body. So just a review lang, 0 to 7, or I mean 0 to 6 is classified as acidic, and 7 is neutral. Above 7, it is classified as alkaline or neutral. I mean alkali or basic. The next water parameter that is very important is also chloride. So chloride is a well-known corrosive inorganic ion that can cause or contribute to equipment failure, such as boiler tube failures caused by acid chloride assaults and steam turbine failures caused by chloride stress corrosion of turbine plates. So magkita chloride is associated with seawater, no? There will be contamination in your freshwater supply. Naging gamit mo as makeup water or feed water for your boiler, no? So, kung may chlorine yan or chloride atong nga feed water, it could cause corrosion sa atong mga metallic parts. No, and if these salt or chloride content maupo dyan sa steam natin, it could also damage other parts, no, other than our boiler. So, it could damage our tubes, it could damage our pipes, no, made up of metals, and worst case scenario, it could also damage our turbine. So it is specifically mentioned to contribute to corrosion fatigue. Nakakabala naman kamo sa corrosion fatigue. May mga cracks, may mga corrosion kita Stress corrosion cracking, ari jutay lang nga crack, malapta siya, and pitting in low pressure turbine. So yung pitting corrosion naton, amo ni siya ang lubak-lubak o nagabuo-buo aton yung mga boilers. So we already know this because we discussed this one last time during corrosion ng discussion. So corrosion, hydrogen damage, and pitting in boilers, and synergistic effects on drum, boiler, and water wall, corrosion in the presence of oxygen and copper oxide. This is according to Cochrane and Rovini, 2012. So magamit ka chloride again, it could cause too many problems inside the boiler, and one of it would be the pitting corrosion. Pitting corrosion. So you already know this discussion on corrosion last week. Next parameter that is important in water analysis is electrical conductivity. So water electrical conductivity, EC, in short, is a measure of a solution's capacity to transport or conduct an electrical current. Okay. So naturally, if we have a pure water is actually a poor conductor of electricity. However, as we also studied last time, water is a universal solvent. So makadissolve siya sa mga ions, sa mga solids along the way. And therefore, that makes water a very good conductor of electricity because it's always not pure ang atong tubig. Now, maka-pure water, lang tayo if you have distilled water. But however, during the process, if that distilled water is being contaminated with other minerals in our system, it could also conduct electricity. So because electrical current is carried by ions in solution, conductivity rises as ion concentration rises. I want you to take note of this. Conductivity rises as ion concentration rises. Nagadamo ang aton nga ions or solids sa aton water, mas nag-conduct siya sa electricity. They are actually direct proportion. No higher solids or ions, higher man ang aton nga conductivity. Conductivity is also used to monitor the build-up of dissolved ionic solids in evaporative cooling water systems in. So again the more nga may aratatang solids inside our water or trapped or dissolved in water, mas naga-flow yung aton nga electricity, mas naga-conduct electricity aton nga water. So when the conductivity gets too high, indicating a potentially harmful accumulation of solids. And so a quantity of water is drained out of the system and replaced with water having lower conductivity. Since this red one is actually an explanation yung naging good conductor of electricity ang water. No? So since pure water does not contain any impurities like calcium, magnesium, sodium, and other salts, which behave as a charge carriers, there are no ions found, and there is the absence of electrons. Hence, pure water does not conduct electricity and as is an insulator. However, again, from our discussion last time, water is a good solvent, so it could also carry with it some dissolved solids or ions with it. The next parameter is dissolved oxygen. So medyo familiar na kami sa dissolved oxygen. This is actually the oxygen being trapped in our water. So once this oxygen is being trapped in water, it could now cause your corrosion. So dapat kabila kami from our discussion on corrosion that any dissolved gases like oxygen or carbon dioxide could potentially cause corrosion in our system, in our boiler specifically, and in our piping systems or tubes if not treated properly. So dissolved oxygen or DO can be thought of a fuel needed for the corrosion process to proceed. So as we all know, corrosion is also a type of combustion, so it really requires oxygen for it to. So rapid corrosion will progress inside an industrial or utility boiler, plus its water and steam system unless dissolved oxygen can be virtually eliminated. So there are different processes and we discussed it last time to dissolve or to remove dissolved oxygen. One of it with the oxygen scavenger with the use of hydrazine. Nakalagay naman pa si hydrazine and other oxygen scavengers like sodium sulfite, no? But however, it's being preferred, hindi na magamit kita sa hydrazine. Other than from the chemical treatment, we also do your mechanical deaeration wherein we let this water, no, we butan ito sa feed water na to pass through a hot surface so that dissolved gases like oxygen or carbon dioxide will evaporate and will not contaminate our boiler feed water na i-supply natin sa tuna. Check corrosion eventually results in expensive repairs of equipment failures and subsequent replacement. So magastuhan kamo sa barko, dugay-dugay welding, dugay-dugay kayo sa inyong mga machineries or sa inyong boiler, no, kung atong focus sa boiler nga. Mabulayan kamo sina since mayara dissolved oxygen ang inyong water hardness. So please do not misinterpret hardness, no, is only applicable to solid. Mga pagkata water hardness, sabi niyo ma-freeze yung water na to, matigay yung atong water. Hindi. Mga pagkata water hardness, it is simply the term used, no, to qualify water having high mineral content. Nataas ang iyang mineral content. No? Like for example, ang pinaka-importante when we talk about water hardness is the presence of calcium and magnesium ions. Now, so kung damo kita calcium, magnesium sa aton ions, we classify it, or sa aton water, I mean, we classify it as hard water. And if jutay lang or almost wala na gid sa calcium or magnesium sa aton tubig, we classify it as soft water. So the dissolved minerals in water produce problems such as scale deposits in hot water pipes and trouble forming lather and soap with soap, I mean. So matingala mo sa mga baka mo, yawan ka mong pabukal sa inyong tubig, no, or sa inyong habon, although may habon siya, yawan ka mong pabukal because it contains a lot of minerals like calcium and magnesium. So hindi siya magbukal. Mayo as compared to soft water. Kaya mo na kung bakit for domestic purpose, no, we need to also understand water hardness. However, in our industry sa marine engineering, hardness caused by calcium and magnesium in water can cause scalings. Okay? So, it can cause scaling, o matilitig ay yung mga ma-precipitate yung solid naton, and yawan takakas ito yung mga tubes. Hindi talaga gusto matabo sa ito nga process along the way. So these ions enter water mostly by interaction with soil and rock, particular limestone deposits. Now, so nag-solidify ni siya, nag-precipitate, and at higher temperature, instead na ma-dissolve siya sa itong tubig, pag siya nga nag-uptake sa ating mga boilers. That's why, this is very harmful also. Later on, you will know nga very important kung naman sa water hardness, kaya ganyan it also cause scaling. Ito may scaling, it could potentially cause problems like explosion, no? Mangita, gito pa, gito yung mga bayatong steam, rang atong tubig, so pwede mag-expand ang atong tank, especially at higher temperature, hindi makagawa siya, hindi siya mag-flow, so mangita siya paagi, hindi siya mag-lupok, or it could cause problems sa ating mga machines, na ma-failure ang atong mga makina, or ang atong mga So there are actually two categories when we talk about hardness. No, temporary, meaning it is only caused by carbonates and can be removed by bottling. Napapalan mo lang yung water mo, then remove na imong hardness. But there are also what you call as permanent hardness, which is meaning after boiling is caused mainly by sulfates and so binawan, the need as ila. We call it as your permanent hardness because all throughout kung mga tubig, even supply chain system may isang nga mga content, no, as it mixed with calcium with magnesium, it could also cause scaling gapon and yawa ka na. The next category or parameter sa aton water analysis would be our iron and manganese. No, iron can be found, or manganese also can also be found dissolved in single ions like Fe2 plus, no, and also Mn2 plus, or undissolved as FeOH3 or MnOH4, respectively. The form in which they appear is determined by oxygen concentration, Fe and Mn compound solubility, In water, pH value, redox potential, hydrolysis, the presence of complex forming, inorganic and organic chemicals, water temperature, and water composition. Para mas maklaro wala nato ang mga makita iron and manganese is actually cause the certain taste no nga matilawan naton sa atong mga water no mga baka ang tubig lang sa yung tubig do medyo pait or medyo lain niya nga sabor. It's mainly because of our iron and also our manganese. So kung makita niyo ang inyong tubig medyo orangey, medyo brownish, it's actually caused by iron. Okay, yung atong nga tubig Opo, no, yung tina nato, no, it could be caused by iron. But once your water is now black, it is contaminated with manganese. Okay? So, black water is caused by manganese and yung reddish brown na yung tubig na nagagawa sa ito ng mga grape at times or sa itong bomba is caused by iron. So iron 2 and manganese 2 ions are oxidized to higher forms in a water distribution system, and this result in the formation of hydroxide suspensions causing undesirable turbidity and color of water. By the way, later we'll be discussing turbidity, but in simple terms, ang makakita turbidity, that's actually the property of water wherein medyo buron or medyo nagalain niya color because of dissolved, not dissolved solid, but because of suspended solids nga rasa. The presence of iron and manganese bacteria in water supply system causes change in water quality. Ang yang abaw lain and at the same time, may bacterial growth kita sa atong pants. Okay, so this is kung microbiology, hindi siya a biological problem. But actually, once this bacteria dies sa atong yung mga tubes or sa atong system, or as it grow, it also cause corrosion sa atong yung mga plants. So it remains wet most of the time and nag-react na yung aton nga mga bacteria sa aton nga mga metals and pwede yan makago na mamatamat ito kapon or mamatamat dissolve yung ating nga metals. Okay? So in the case of occurrence of iron 2 and manganese 2 ions at the consumer's point, iron and manganese are oxidized and precipitated under suitable conditions. So, washing machines, no boilers. So following the above mentioned facts, higher concentrations of iron and manganese in water cause technological problems, failure of water supply systems operation, water quality deterioration, and concentrations of oxygen. They form undesirable scales that result in a reduction of pipe flow cross section. So yung scales, aside from mechanical failure, this is also a problem in terms of your thermodynamics. Hindi ka makaproduce heat because your metal surface na which is actually the main point or main area kung di nga cause ato ng heat transfer na nag-occur ang ato ng heat transfer would be lesser na because of this particular scales no nga ara sa aton nga mga metals. So hindi ka makaproduce mayos ang steam, and hindi ka makaproduce mayos ang steam wala sa mga drive sa atong turbine to produce more power and to be converted into electricity. So makaproblema ka mo along the way sa inyong mga operations. The next contaminant is silica. So we actually use silica with sand, no, but they're actually quite different man in terms of earth science. So silica is the only boiler water salt that vaporizes below 2,400 psig. What does it mean? No, so even at lower pressure, this silica could be contaminating our water, no? Or atong nga steam gali, I mean. No, as our water boils, nga may silica, tapos mangyayari ka mag-produce ng steam, since the silica is actually pwede siya mag-evaporate at lower pressure, pwede gito siya mag-upod sa itong steam, libot-libot sa itong mga particular parts, no? Sa mga parts naton sa itong system, and pwede ito maproblema, no? Makakauses ng scaling sa itong turbines. No, so ang malaki naman ay silika, kaya dasig siya mag-evaporate upod sa itong steam, kung pwede ito siya makakause problems sa itong turbines, especially tawag sa scaling. So silica scales are typically extremely hard, glossy, and difficult to remove. Nayawan kini kakasa ato nga silica scales no nga makita sa ating nga turbine. Siya crystalline form. So thermal conductivities are typically quite low and even very small silica scales can cause tube failure. So pwede yato magiba ang aton nga mga tubings no kung may nakita sang silica. That's why it's a no-no. No, kung may makita ka mga silica, even in industries here on land, no, sa aton nga mga, like for example, when we had our OJT sa first farmers, once may silica content ang atong tubig, na ginagamit, actually, gina-remove, nila, nila ginagamit sa system because dako sa problema ng mahimo sa silica. And same with you, no, or same with us in the marine engineering industry, industry mismo. The next contaminant would be sulfides. Hydrogen sulfide and sulfides of the alkali and alkaline earth metals are soluble in water. Soluble sulfide salts dissociate into the sulfide ions that react with the hydrogen ions in water to form the hydrosulfide ion or hydrogen sulfide. Okay. The relative concentrations of this species are function of the pH of the water. Hydrosulfide concentrations increase with decreasing. Nagadamo yung aton ng hydrogen sulfide when we decrease our pH. And when we have decreased pH, we can now have your corrosion in our system. Okay? So yung sulfides naton, yan, as could really cause corrosion. And kabula naman ka mo, H2 is also corrosive, no? So ma-damage siya ginatong yung mga mechanical parts. Sulfate levels above the 50 milligrams per liter may make the water taste bitter or like medicine. So mabait yung tubig if we have sulfates. High sulfate levels may also corrode plumbing, particularly copper. Now, sa sulfate na to, nag-react sa itong copper. If we use copper as our tubes, no, or sa itong pipes, you can see yung greenish blue nga do tuktok nga na sa quartz. Actually, it also a form of corrosion, no? Pero this time, na yung color niya because the element that that's being corroded is not iron, but copper. Sulfides is frequently used in water treatment applications as an oxygen suppressing agent. In boiler water, sulfite is used to eliminate dissolved oxygen in feedwater, which could otherwise promote corrosion within the. So we use sulfites to remove oxygen. But again, ginseng lang ito natin sa lanigan, yung sodium sulfite natin could also cause other contaminants no, sa ating water. So yung preferred kid natin for water treatment, chemical treatment, would be hydrazine. However, if ang available sa ating bark is sulfites, then meron man siya necessary nga steps on how to use it. So sulfites. Total solids. When talk about total solids, it could either be your dissolved solids, no? Yung hindi natin makita using our naked eye, those are dissolved solids. And those nga visible sa to naked eye are your total suspended solids. Okay? So the suspended particles are held on the top of the filter while the dissolved solids flow through with the water. So, matay lang ko sa inyo, isa ka filtration sa tapa, ipa-check ka lang. O nagkakatabo, once there are dissolved water, suspended solids at the system. And once you filter it, will tap into water. Okay? So if a part of the filtered water sample is placed in a tiny dish and subsequently evaporated, the solids remain as a residue. Total dissolved solids, or TDS, is a common name for this substance. So kung permit lang gina-evaporate, ginapabukala lang atong tubig, especially that happens inside our boiler class, may tendency nga may mas solids nga magtig-ah. And those are our dissolved solids. Una, hindi siya makita, no? But once you boil the system, no, atong tubig, ginainit naton sa atong boiler, it can cause now your problems sa atong nga system, sa atong boiler kit. Okay. So again, yung mga sa itong filter are your total suspended solids. And yung clear na tubig na ating natin safe na, it also contain your dissolved solids. So pagbukalan, makita natin yung may solid gali, no? It could be salt crystals or other particles, no? Or minerals nga na sa kanya. So those are your dissolved solids. So makita nato 'no, it's actually associated with turbidity. Yung cloudiness, ang atong tubig is highly dependent on the suspended solids, I mean ha. So these are substances that will dissolve in water. The principal ones are the carbonates and sulfates of calcium and magnesium, which can are scale forming when heated. The total amount of dissolved matter, excluding dissolved gases, is determined by evaporation. So yung turbidity nato niya, are yung atong suspended solids, pwede lang siya ma-filter out. No, but not all of the solids pwede siya ma-filter out. So you need your evaporation. Evaporate mo gid siya para mabalaan mo kung may solid particles kinabilin si mo nga water sample. So total suspended solids, these are solid substances that exist in water as suspended particles. They are usually mineral or organic in origin. Undissolved matter causes turbidity and can plug lines, deposit in heat exchange equipment by boilers, etc. Yan siya ang tsura, siya ang turbidity. This usually happens when your water has sand particles in it or other organic matter nga nagkaka-decompose sa inyong tubig. Okay, so simply to remove this, you just need to use your filtration setup. Na ma-filter mo man lang niya siya, but yung dissolved solids naton, laing nga process ang himuon naton para ma-eliminate yung atong dissolved solids. Okay, so speaking of turbidity, is the cloudiness of water is referred to as turbidity. Okay. Suspended particles in water such as clay, silt, organic material, plankton, and other particulate elements, causes your turbidity. This is actually what happens when we have a heavy rain, overnight. Kung magulan, we can see that the river is actually not clear in color, but now contain a brownish appearance. That's because of the clay or silt na nagpo-hold sa tulo. Okay? So, imagine nakabuk, no? Kung natong supply, fresh water, contaminated or removed sa soil or silt or other ng mga substances, pwede maging turbid ang ating tubig. Taas ng turbidity. Because also of high solid, suspended solid content. So the unit of turbidity is actually NTU, no? The unit of turbidity is NTU, nephelometric turbidity unit. NTU stands for nephelometric turbidity unit. Now the unit used to measure the turbidity of a fluid or the presence of suspended particles in water. Okay. So haninad ni sila ha. The total suspended solids can cause your turbidity. By the way, as if you could remember earlier, yung atom electrical conductivity is also dependent on the solid content. Higher in mga solid content, taas ang imong electrical conductivity. And that's mainly because of dissolved solids. Mga pagkata dissolved solids, those could be your ions, minerals in your water. Okay. So total dissolved solids is paired with electrical conductivity. Suspended solids is paired with your turbidity. Okay, remember that. And the last portion for our water analysis, water parameters natin will be microbial content. Cooling water systems, particularly open circulating systems, provide a favorable environment for the growth of microorganisms. Microbial growth on wetted surfaces leads to the formation of biofilms. And these biofilms, at the long run, pwede siya makakos ang corrosion. Okay? So, ang magkata biofouling, later discuss na siya. If uncontrolled, such films cause fouling, which can adversely affect equipment performance, promote metal corrosion, ang corrosion, gidya po ng effect niya, and accelerate wood deterioration. If it nagtapit ka sa wood na. Okay? So, aton yung concern is metal, it could also corrode your metal. And amo ni siya nga tawag na ito nga biofouling. Okay, kung baga, kung makakita ka mo sang beehive, no, damo sang buyog, putsukan, for example, nga nagatambay sa muna nga nest nila or hive. So, mga pagkita biofouling, tanan yung mga microorganisms, no, pwede mga shells gani, no, or mga other, mga small nga mga crustaceans, pwede siya magtapik sa mga metal surface, causing corrosion. Okay? So biofouling or biological fouling is the accumulation of microorganisms, plants, algae, or small animals on wet surfaces that have a mechanical function causing structural or other functional deficiencies. So as in, matuktukan ng inyo nga mga metals, kaya matapit yung mga animals ninyo. And if you will recall your other topics also, we do the ballasting method, no, or process para yung mga gagmay ng mga crustaceans, no, uh, or mga microorganisms mapatay or ma-eliminate siya during the process nga nagatugong katubig, no? Eliminate naman siya through the deballasting process para mahulog ng mga sapat-sapat ng silong. So that's all for now sa aton nga topic on water parameters. But this is simply an introduction pero general ni siyang approach ang akong ginubra, no? Tanan na discuss naton sa aton yung water parameters. Later may specific kita effects of fresh water, no, and also the seawater. Ang problema ni di sa item medyo sulit-sulit and sulit-sulit para may understand nyo man. And amo na siya ang design sa aton nga Ched Marie. So, I hope you will understand, no? And I hope matun-an yun yung amo na nga topic kay very important is inyo nga. Okay, thank you for